In section 3.3, we're going to look at common factors of a polynomial. What is the greatest common factor? Well, greatest common factor between the following numbers, 12 and 18. So if I look at 12 and 18, what's the biggest number that divides evenly into both of those? And the greatest common factor here would be 6. If I was to look at 4x and 8, the greatest common factor would be 4. And if I look at 3x squared and 9x, well, I can divide 3 into both of these terms. I can divide an x, so it would be 3x. Polynomials can be consist of many terms. We could have a 2-term, a binomial, like a bicycle. Okay, we could have 3 terms, which is a trinomial. We could have 1 term, which is a monomial. So a polynomial consists of many terms being added and subtracted together. All right, to begin with, let's look at how we multiply monomials. So if we want to multiply 5x by 2x, okay, we multiply the coefficients together. So 5 times 2 would be equal to 10, and x times x would give me x squared. Remember, for our laws of exponents, if we're multiplying x and the bases are the same, we leave the base and we add the exponents. Question B, again, the coefficients. The coefficients, again, are the numbers in front. So 2 times 3 would be 6, and x times y would simply be xy. Now, a review from Math 9, we have the distribution property. So that's when we multiply a monomial by, say, maybe a binomial in this example. So the first thing I'm going to do is I'm going to distribute the 4x. So when I do that, I multiply 4x by 5x. So 4x times 5x, 4 times 5 is 20. And x times x is going to be x squared. And then 4x times negative 3, well, 4 times negative 3 is negative 12, and the x tags along because there's no x to multiply by in the term of negative 3. So there would be the expression when you multiplied those two terms together. Now, factoring polynomials means that we are breaking down a polynomial into its factors. So it's the reverse operation. So it would be going from something like 20x squared minus 12x into something like that. So that's what it means when we factor. So let's take a look at the following. We want to factor each binomial. Well, if we look at 6n plus 9, we want to look for the greatest common factor. And the greatest common factor for 6 and 9 would be 3. So we are going to factor a 3 out, which really means I'm dividing each term by 3. So 6n divided by 3 would be 2n, and 9 divided by 3 would be 3. In question B, I have 6c plus 4c squared. So I look at the coefficients, 6 and 4. Well, the greatest common factor is 2. And I have a c and a c squared, so I could also factor out a c. So 6c divided by 2c would be 3. And 4c squared divided by 2c would be 2c. One way you can check if you're right is you could distribute back and see if you get back what you started with. So you should get back that when you distribute c into the binomial 3 plus 2c. Okay, I want you to pause the video and give this one a try, these two a try. Well, hopefully you've had a chance to try these. So in question A, I'm hoping you found that the greatest common factor was 3. And when you divide 3g by 3, you're left with g. And when you divide 6 by g, when you divide 6 by 3, you're left with 2. In question B, when we look at the coefficients, our greatest common factor is 4, and 1d would be common to both. So 8d divided by 4d would be 2, and 12d squared divided by 4d would be 3d, and there would be your two factors for that polynomial. All right, what happens when we have a trinomial? Okay, well, if we take a look at the trinomial here, I have 3 terms, and the only thing that's common to all 3 are the coefficients. I could factor a 5 out. So 5 divided by 5 is going to be 1, minus 10z divided by 5 would be 2z, minus 5z squared divided by 5 would be z squared, and that would be your final answer. Okay, I want you to take a turn and try the next one. Okay, hoping you tried it. And if you factor out a 6, 6 is common to all three coefficients. Again, 6 divided by 6 is 1. Lots of students forget to carry the 1. They just eliminate that term. But again, you're still going to end up with a trinomial here. 6 into 12z is going to be negative 2z. And 6 into 18 is going to be 3z squared. And that would be your final answer. All right, let's try trinomials now that have coefficients and two variables. So again, I look at my coefficients, negative 12, negative 20, negative 16, and my GCF would be negative 4. Then I have an x cubed, an x, and an x squared. So at least there is one x common to all, and I have a y squared, and another y squared, so I could take out a y. So that's going to be my greatest common factor. So negative 12 divided by negative 4 is going to be 3. X cubed divided by x. Remember, if you're doing x cubed divided by x to the first, you leave the base and subtract the exponents. So 3 minus 1 is 2. So that's going to be x squared, and the y is factored out, so it's gone. In the second term, negative 20 divided by negative 4 is going to be plus 5. I factored the x out, and y squared divided by y is going to be y. Finally, I take a negative 4 out of negative 16. That's going to be 4. And I'm going to be left with 1x and 1y when I factor out an xy out of x squared and y squared. All right, again, I'd like you to pause the video and try this question on your own. All right, hoping you've tried it. Again, looking at the coefficients of negative 20, negative 30, negative 25, we see that negative 5 is common to all. And 1c is common to all, and 1d is common to all. Negative 20 divided by negative 5 is going to be 4. And I'm going to be left with a c cubed. And when I factor the d out of that first term, it's going to be gone. Now I'm going to divide negative 5cb into negative 30c cubed d squared. So negative 5 into negative 30 is going to be positive 6. C cubed divided by c is going to be c squared, and d squared divided by d is going to be d. And finally, negative 5 into negative 25 is going to be plus 5. And I've taken both the c and the d out, so I'm just left with the coefficient of 5 in that last spot of that trinomial. And there would be your final answer. Okay, another skill we're going to learn in this section is factoring by grouping. So right now, if you look at all 4 of these terms, there is nothing common to all 4. However, there is something common to these 2 and something common to these 2. So in the first 2 terms, I could factor out a b, and I'd be left with a plus, well, when I factor b out of a b, I'm left with a 1, because b divided by b is 1. And in the next one, I could factor out a positive 2, and I'd also be left with a plus 1. And when you're factoring by grouping, the reason we do factoring by grouping is we're hoping to get this common factor the same here. So now, this is really one term still. This is really one term. So I'm going to take out the greatest common factor of these 2 terms, which in this case would be a plus 1. So if I remove the a plus 1 from these 2 terms, I'm going to be left with b plus 2 as my other factor. So if you were to multiply these together by distributing the a to both terms and the 1 to both terms and collect like terms, you should end up with what you started with. Okay, in this particular question, again, we have mx plus qx plus my plus qy, and again, nothing common to all 4, so I'm going to try grouping again. So in the first 2 terms, I'm going to factor out an x, and I'll be left with m plus q, and then I'm going to factor out a positive y, and I'll be left with m plus q, and again, the m plus q is common to both, so I'm going to factor it out. And when I bring the m plus q out, my other factor that's going to be left is going to be x plus y, and that would be your final answer. Okay, in this particular question, again, I'm going to settle up by grouping. Again, grouping the first 2, grouping the last 2. And I'm going to factor a 2s out of the first two terms, and I'll be left with r plus 2. And we have to do some deductive reasoning here. I have to figure out what can I factor out of these two terms so that what's left in my brackets after I factor is going to be r plus 2. And hopefully you see if I factor out a -1, I'll be left with positive r plus 2. Now I have positive r plus 2 that's common to both terms. I'll factor out now the r plus 2, and I'll be left with the 2s minus 1 as my second factor. Okay, sometimes it might be advantageous for us to regroup things, okay? So in this particular case, let's just see what we can do here. If I was to rearrange the terms in this polynomial first and write x squared y minus 3x cubed minus 2y plus 6x, and now I'm going to do some grouping. So if I factor out x squared out of the first two terms, I'll be left with y minus 3x. And if I take a -2 out of the next two terms, I'll be left with y minus 3x. So again, these are going to be identical, so I can factor out a y minus 3x, and I'll be left with x squared minus 2 as my other factor. So again, sometimes when we do grouping, you have to rearrange the terms in order for your grouping to work out. Okay, that concludes section 3.3. So there is your assignment on page 154 to 156, and there's also a handout that you were given in class to work on.